Hey everyone, the genetic disorder that I decided to research was beta thalassemia. So let's learn a little bit more about it. What is beta thalassemia? Beta thalassemia is a blood disorder that affects the hemoglobin production. I'll talk about hemoglobin in a little bit. There are three different types of beta thalassemia: major, intermediate, and minor. These are differentiated based on the severity of the symptoms. A little history behind beta thalassemia is that it was discovered in 1925 by Thomas Cooley. So sometimes this disease is referred to Cooley's disease. We didn't know a whole lot about it, but we knew that it was affecting a lot of people. In 1948, we learned that it was associated with hemoglobin. So now we had a cause and we could study it a little bit more. Blood transfusions were used as treatment during this time, and they are still used today. In 2007, gene therapy started to be used as a treatment, which is a very important advancement in this disease. The prevalence of beta thalassemia is really important because it is still a very big disease worldwide. Thousands of infants are born each day with beta thalassemia. It does have a regional effect, though, mainly developing countries that are in North Africa, Middle East, India, and Southeast Asia. It tends to be in similar areas where malaria is present. The symptoms of beta thalassemia is anemia. This causes fatigue, pale skin, and weakness. There can be some really severe symptoms, though, including blood clots, no weight gain, yellowing of skin, an enlarged spleen, and delay in puberty. Most of the time, the onset of symptoms is about 2 years old. They may not be as severe, though, and as the child develops, that's when we start to see the delay in puberty, which can be an indicator that beta thalassemia might be present. So here we go. This is hemoglobin. This image over here, you can see there are 4 subunits. There's 2 alpha units and 2 beta units. There's also heme groups, and the function of hemoglobin is to carry oxygen. So that's the normal cell in the normal function of the red blood cell in the hemoglobin. But when there's the beta thalassemia, there is a mutation in the HBB gene, which codes for the hemoglobin beta subunit. So normally the HBB gene makes the beta globin to make a functional hemoglobin unit. When there's a mutation, there's the improper production of hemoglobin, resulting in a different fold so that it does not look the same and will not have the same function, so it cannot carry oxygen as efficiently, which results in the anemia. Different mutations can occur, like point mutations, which substitute different nucleotides, and an example would be the missense mutation, where CTG turns into CGG, where leucine turns into arginine. These are completely different proteins which code for different amino acids which code for different proteins and result in completely different folding for the beta globin subunit. So here is the mode of inheritance. For beta thalassemia, this is an autosomal recessive disease, meaning that you need to have 2 mutated alleles, to develop this disorder. On this side, I have 2 different Punnett squares. This first one has a dominant parent that has 2 dominant alleles, and then the second parent is a recessive parent where they have 2 recessive alleles. This parent has the disorder, while this one does not and is not a carrier. They produce 4 children who are heterozygous, meaning that they are all carriers for beta thalassemia, but none of them will develop the disorder. Then, in this Punnett square down here, there's an example of 2 heterozygous parents mating. So these are both carriers for the disease, and let's see what type of children they can produce. They can produce a homozygous dominant child, which will not have the disease or be a carrier. They have 2 heterozygous children that will not show any signs or symptoms, but are both carriers. And then this is the important one right here, which is a homozygous recessive child, meaning they will develop the disease. It is important to recognize that autosomal recessive skips generations. In this image over here, both of these parents are carriers. And so then these are their 4 options of offspring. This one right here has the disease, meaning they have a 25% chance of producing a child that will develop beta thalassemia. This is an example pedigree showing the beta thalassemia trait amongst a family. At the top here, we have Bill and Nancy. Nancy has the, beta thalassemia, so she is homozygous recessive for the disorder. Bill is the carrier, but he does not show any symptoms. When they produce 5 children, 2 of them have the disease. Okay? On the end here, there's Matthew, though, and he does not have the disease, but we can see that he is heterozygous, meaning that he is a carrier for beta thalassemia. When he mates with Audra, who is also a carrier, and they produce 5 children, 2 of the children have beta thalassemia. This is a perfect example showing the autosomal recessiveness of this trait because it skips a generation. Neither Matthew nor Audra have the disease, but they are able to pass it on since both of their parents have the disease, so they are now both carriers. When we're diagnosing beta thalassemia, this can be done through a CBC blood test. This is very common and can be done at many different clinics who have labs, and a general provider can order this test. When they get the blood draw, then they look under the microscope to look at the different cells. They can see a difference in shape. Over here, this is a normal red blood cell. You can see it's very circular. And then this is one that has beta thalassemia. You can clearly see the difference in cell shape, and this is because the functional unit of hemoglobin has been altered. There are different genetic testings that are optional for this disorder. You can get molecular genetic screening where that can be carrier screening or pre-implantation screening, and these take parts of your DNA and analyze it to look for different mutations. This can be very costly, but depending on where you go, some insurances may be able to help. The CBC blood test is only about $100, so if you wanted to wait until your child is born, you can just get the test on then. The carrier screening is important, though, if you want to be tested before you start reproducing. Early detection is very important with beta thalassemia because it is treatable, and you can have a significantly improved quality of life if you get the blood transfusions early and maybe even start the gene therapy. An example of a company that does the genetic testing is Myriad's Women Health. They do the carrier and pre-implantation testing and are very helpful because they can test for other genetic disorders besides beta thalassemia. The cost varies, and they won't give you an estimate until they can talk to your insurance company and see what they have. And then they do need a referral from a primary provider. I think this is really important because the primary provider should be involved in any medical decisions that you make, and they should be notified that you're thinking about undergoing genetic testing, especially if you're thinking about reproduction. They would like to know the results too, because that might affect any other symptoms that you come in or any other treatment that they would want to undergo for you. So that was a little bit about beta thalassemia. Here are my references for this research, and I hope you guys learned something. Thanks.